In the past, I've tended to recommend that if you want a decent USB power supply, go for a prominent brand, and I've recommended the Apple one, not because I'm an Apple fanboy, but because Apple's a huge American brand and they want to protect that brand, and they take things seriously, so their power supplies are well made. Likewise, I'm hoping that this IKEA one is good too, and we're going to find out shortly because I'm about to open this up. The Squeeze one, yes. After finding this one was live at 240 volts, that was that really drove home the message that you have to, these things are so important. We need 5-volt power supplies. We need USB power supplies because from, things like the phones to lights, we plug lots of stuff into 5 volts. It's become an industry standard. So it makes sense to get yourself a beefy, chunky, good quality supply that's safe. And when you buy what look like Apple, and you get them fairly cheap, or even pay full price, but get them from a non-authorized source, you could be getting something like this that is based on one of the Apple chargers. But this one in particular is notable for the fact it's got 0.2mm separation between the mains and the low voltage side, so it's therefore a complete death trap. Likewise, this one that is printed Samsung, but is really not Samsung. I mean, I don't think Samsung would put something like this out, because it, again, does not have any proper isolation. It's just, they've just run the tracks at the same distance as everything else, so it's mains here, low voltage there, so again, not safe. And then you get the brands like the Tiger. Now, I've already opened one of these. It was a little purple version of this. I quite like these because all the colours. But Tiger is a sort of like similar to IKEA in a way. It's sort of novelty stuff, and they've got shops all around the world. And this one seemed actually pretty good. It was very much a cut above the cheap generic ones, but I don't think it was quite up to the standard. Well, hopefully I've not opened one of these yet. I'll soon find out. But I wouldn't expect it to be up to the standard of things like the Apple one or the IKEA one, because this is a lot cheaper. It's something like £5 with the lead and stuff like that. So let's take a look at let's get all the lesser ones out the way, and I'll just move this one slowly out of the way because it's not quite so lesser. It's actually, I use these, I think they're okay. And we'll take a look at the Apple now. Here's a weird thing. The Apple charger is modular. It's designed to be used in various countries, so it comes with various adapters. And it's got this metal pin in the back, and it's not just for anchoring things. This metal pin is connected, not directly, but it is connected to the negative rail of the, it's connected to the shell, so there is a reference to Earth. But strangely, although this has got a metal earth pin, it's not got the matching connection in here. I don't know why they did that. So it's not earthed. And this one has what you might call good suppression, RF suppression circuitry, as you'd expect from a company like Apple. But that means that of all the units I tested, this one was the most likely to give you a tingle, because it had quite a high leakage current of about 100 microamps. This one, I've tested the leakage current. It has a leakage current, the IKEA unit, of 64 microamps, which is typically what you'd expect. They're classing it as a double insulated unit, and I'm guessing that, as with IKEA the instructions with IKEA come in about 35 languages, so they use these in every country, and not every country has earthing. So I think they just base it on unearthed supplies, and in this case, they could have added that extra metal pin, but they just class it as a double insulated appliance. And you are likely, in some scenarios, you'll get a very faint tingle, particularly in the back of your hand if you brush against something while you're holding an object that's plugged into this. It's just the nature of these power supplies and switchboard power supplies. But the IKEA unit is rated 3.4 amps. I've given it a good test. I've tested it up to 2 amps and it held the voltage absolutely fine. So let's just open it. And this is where I'm going to have a go at opening this. And I know from opening previous IKEA products that they're sometimes quite hard to open. They're really snapped together very well, and it might even be glued, I don't really know. So if this doesn't come apart quickly, then I'll pause just so you don't have to experience the excruciating sight of me bursting the case open. Yeah, this thing is, I can already tell this is going to be chewed up. So yes, I'll pause the video and I'll be back shortly. Okay, that wasn't too bad. All it took was a few taps of the hammer and then the pipe grips into it to actually burst that case open. It appears to be, it's quite nice. It's got these plastic pins that push into here. I'm not sure if that's just for alignment. I got the feeling it was glued, but maybe it's not. It's not overly 100%. I'm not seeing the shredded remnants you'd normally expect from glue. All I'm seeing is shredded remnants where I've used unreasonable force. So it must have been glued because it's not really going back together that easily unless these pins are tight friction fit. But anyway, I digress. Let's get into it. And you know what? I'm just going to cut that off. Let's cut it off so we can take a good look at this. I'm going to be destroying this completely because as we've discovered from the Squeeze unit, just because it looks like a good transformer doesn't mean it is a good transformer. So let's see what this is using. Little switch mode power supply chip is, it's marked 1699-02 R51GH. I'm not 100% sure that is. Okay. Let's just say generic switch mode power supply. So we've got the mains come in here. We've got what looks like a little inrush current, NTC1. It's a negative temperature coefficient thermistor. Now these are little resistors, basically, heat sensitive resistors that start off with a fairly high resistance, and then as they heat up it goes lower, and that means that when you plug it in, initially it stops that huge surge of current in, because what's happening initially is that the current's going through this bridge rectifier and charging these capacitors, which I haven't discharged, but I now have now because I've stuck my finger across them. Oh, look at the separation. Oh, look at the spark gaps and everything. This is like pro. So the mains comes in, it gets that nasty surge in, just limited by this NDC thermistor, which means if you've got lots and lots of things plugged in and they, suppose you had like a multi-way adapter with lots of these plugged in, it means it's not going to be such a high surge that it's going to cause things to trip out or crash. Then it's got a common mode inductor, which is an inductor with the live and neutral wound round it in sort of opposite directions, so that low frequencies like mains 50 Hz will just pass through it without any effect, but high frequency noise or transients will effectively induce a magnetic field that cancels each other out because they're going in opposite directions. That then goes through a bridge rectifier, which is a surface mount one with good separation all the way through. It's tacked. The solder connectors are on each corner for maximum separation, a smoothing capacitor, a choke, another smoothing capacitor. So this looks like they're making an effort for good filtration. Then we've got the little switch mode chip and its transistor. We've got the transformer here, which I'm going to have to take to bits, obviously, because there's no other way we can actually determine, although it looks good, it looks quite nicely made, we don't know what's inside, so I'm going to remove that. I'm going to desolder it, and then we'll investigate what's in it. It feels a criminal thing, taking this power supply, to bits and ruining it when it's a perfectly good working power supply, but if I do it, you guys don't have to, so that's the whole point of this channel. Well, one of the points of this channel. So we've got the output goes through this heat sinked diode, and then it's got these little, I see this quite commonly in these ports, it's got these tiny little chips that are being used to, and the text is absolutely minute on them. It really is. I'm going to have to actually take a look through a microscope at that text. It's absolutely... They've tried to put a whole chip's number onto a tiny little SOC 23-ish type package, which is so small that I'm not even finding it here. Where is it? Oh, I'm not finding it. It says 198AD, if that makes any sense. I guess they're all the same. I think it's just one per port. Yes, 198AD. And I'm guessing, and underneath it says GJCER. I'm guessing those are for negotiating how much power the USB device can have. This thing says about 2.1 amp max per outlet. And these little chips tend to basically be connected across the 5V and 0V, and then the two outputs of the chip are across the data pins. So this is actually just providing some sort of communication to the device that's charging to say, you know, you can take the maximum, you can say take 2.1 amps if you want. The capacitors on the output have been kept away from the diode's heatsink, which is nice. Not so much there, but it's still enough spacing. And it's got the Class Y suppression capacitor. It's got absolutely mega gap there with an actual routed section out there. And the little spark gaps, 2 spark gaps, which I'm guessing is for when you've got an electrostatic discharge on the output. You know, if you go to plug something in, you've got a high static charge. It means that if the voltage exceeds the rating of all these components as a last resort, it can jump physically across as a spark. But that would be about 10 kV. That would be quite a high voltage. The Class Y capacitor, is that 10 nano? No, it must be 1 nano actually. Yeah, 1 nanofarad. Okay. Right, so now I have to take this transformer off, and that means cutting it, trying to get it off the board. At least it's a single-sided board, but I shall be back in a moment. That was actually fairly easy to get out, helped greatly by the fact it's a single-sided board. I like the way that the pins are sideways on this side, but long ways on that side, just to make sure that there's no confusion about the way the transformer goes round. It's the usual configuration. It's got the primary winding plus a second winding on the main side that provides power to the chip. But in this case, it's not purely what's called a bootstrap winding. You get bootstrap and feedback, or sometimes they're combined. Bootstrap is when it provides power to the chip itself. Once the chip has started, when you plug it in, there's usually a slight delay, as the capacitor, in this case, it's this tiny little thing here, charges via a high-value resistor. And once it's got enough charge in that, then the chip itself will burst into action, and as soon as it does and starts driving the transformer, then it effectively provides its own power supply from that auxiliary winding. But that's also used sometimes for feedback. It will monitor the voltage in that, and it does seem to be doing that here. In fact, this is, for a modern switch mode power supply, this is a lot of support components. It's really quite a complex unit. And the other winding, the third winding, is of course the supposedly isolated secondary, which is going out to the 5V circuitry, and the bit you're going to be touching. So let's take the tape off this transformer and take a look inside and see what the quality is like. At the moment, I am seeing that the main side windings are all kind of sleeved, which is good. It does look like an effort has been made to actually make it relatively safe. Now, where is the end of this? Oh, and it's actually got a number on it with a date as well. That's quite good. Let's see if we can get this tape off, so we can get the bobbin apart and take a look inside it. Now, how is this thing stuck together? It's looking quite odd, actually. The core is actually in a plastic housing in this as well. It's not just a straight metal core around it. How does this come apart? I may have to pause again. This is not really immediately obvious how this comes apart. I think it may involve force. I'm just going to poke that with a screwdriver first and see if I can push that down. But I think the thing may actually have all been sealed up. It's not clear at all. I shall pause. Well, this definitely isn't going back together again. That was just well glued together, and I have to say there's an interesting thing. There's a little extra wire from here which is connected to the negative rail of the power supply, and it's just a bare bit of copper wire. They've tinned it, and then it was wrapped around the ferrite core itself, just actually glued effectively by the lacquer onto the ferrite, as if it was maybe to screen the ferrite. I've not come across that. That's quite odd. So let's go in further. The first wind I'm expecting is going to be the sort of bootstrap wind because it's or feedback, because it's not that critical in the sense that it's not the high current winding, so it's sort of it gets the last connection, so to speak. So it's coming from that side and terminating, let's see, oh, this might actually be part of the primary, by the look of it. Okay. Because it does look like this first wire is coming from what looks like one of the primary connections. Yeah, that's connected to the plus 5 volt rail. So that is one of the primary connections. Okay, let's cut it. And it's sleeved up just till it's a really short section of sleeving they got in it just to get it under the cover here. I wonder why that is. Let's unwind this anyway. So this looks like part of the primary. And so far it's not going too close to the secondary, and the secondary does have that thick insulation which is intact, which is good. That was the weakness, that was the failing point in the squeeze unit. The secondary insulation had been violated. So this winding comes round and it goes to a midpoint tap. So that was part of the primary winding. I shall cut that off, get it out of the way. And we shall go on to the next layer. This could be the bootstrap feedback one, or this next one could be, it looks like the bootstrap feedback. Odd. There's just a couple of tails that aren't connected to anything, just a cluster of wires. I haven't broken that, have I? Could that just be sensing it single-ended? That's odd. I didn't see that connected to anything in there. It just seemed to be just tucked up and under the insulation. Okay. So this is actually a cluster of wires. Could they be relying on capacitive coupling between them or something? Or is this... That's weird. That's something that's new to me. Almost like it's a capacitively coupled feedback winding, but also providing power to the chip if it's going to those two pins, if it's going to these two pins, which it may do. I shall find out when I get to the end. Now it's ducking underneath the next layer of insulation. Oh no, it's going, all those wires are connected to one pin. That's weird. Oh, that's a screening layer. Because there are two more windings going in here. Okay, so that's a screening layer. That's the equivalent of the piece of copper tape that was in the squeeze supply. So that whole winding was actually just a cluster of wires. It looks like 3 wires just clustered together. Yeah, it just looks like a cluster of 3 wires together with just one connection at one end and just wrapped round, so they are some sort of screening effect. But yet part of the primary was outside that. That's weird. Sometimes I think this, you know, the switch mode power supplies is a bit of a black art at times. The high frequencies that operate at, just normal rules do not apply. It's clear that quite a lot of thought and technology has gone into this one. And then I took it to bits. Okay, I'm trying to find the end here. It's being elusive. There's a point that when they put this tape round and then wrap it tightly, it really just bonds onto itself. To the point you can't actually see the end. So off comes the next layer. And what are we getting now? Now we're getting the secondary. So where the secondary crosses any of these other connections, like the bootstrap feedback type connection or the primary connection, they have also sleeved the primary, as well as the fact that this is a double insulated. So this is a pair of cores. And they're relying primarily on the double insulation on this and the sleeving of those other connections for the separation, which is reasonable enough. It is quite thick insulation. And it's intact, it's not been chaffed off as in that previous horror, the squeeze one. So yep, a very stout, thick insulation secondary. And now we're into the inner layer, which is still going to be, it's going to be the feedback. I wonder if that's the very middle one or not. I'm not really sure, and I'll find out when we peel this off what's going to be next. Next is the feedback winding, by the look of it. And again, it's a series of so this is the pin that's going to the middle, so that's actually the one that's going to power the chip via a diode. And that is quite odd in that it's another cluster of, is it 3 or 4 wires? 3, I think. That's very hard to tell actually. Yeah, it's 3 separate cores. And I'm guessing this is probably, and this is where I make a fool of myself when it isn't, connected to the negative, which is there. Okay. Righto, yep, that is the feedback winding. And that just leaves the final section of the primary winding. So far it does look like it's been a sensibly designed transformer, and care has been made, you know, taken in making it. So coupled with the other features here, the isolation features, this does look, as you'd expect from IKEA, it does look quite a well-designed supply. Surprised amount of circuitry on it, it's very heavy on the circuitry side. And this is now just coming over to the primary side. So if I cut that winding, that is the loop by the look of it. That's where the centre point, where it's actually, this was where this winding here was connected to the outer winding, the very outermost winding. And then fundamentally, I'm just expecting a plastic core in the middle after this. Good number of turns, because it is the primary after all, it's the main side that's effectively switching about 300 volts in this case from the capacitor, and yes, it is just a plastic core, and it will be going to directly to one of those pins, which is that pin. Yep, so it's an unusual transformer. It's very complex, you know. I'm surprised the amount of support components in this. But everything seems to check out in the transformer. It seems quite well designed. It's got good filtering. It's got the inrush limiting. It's got the modest, beefy little heatsink on a supported heatsink. It's not just flapping loose, as is this side and the other side for the diode. It's got the good separation gaps, spark gaps. It's got a slot through between the mains and the low voltage where the windings come off. And the transformer itself seems to be quite sensibly made, and it's got the support circuitry and the capacitors are mounted away from the heatsink. So, you know what? This looks okay, particularly given the way it's designed to mount is such that any heat from that heatsink will be going up to the top of the plug, further away from those capacitors, and there'll be a bit of air circulation. I mean, I can see holes in the USB casings, so there's going to be a wee bit of air circulation in there as well, when they're not all stuffed with plugs, which is the point they'd be under the most load. But on the whole, you know, and also these cables are huge. It's not just the wee flimsy things you find in the Chinese plugs that, you know, it's just wee dinky thin wires. These are actually quite heavy rated cables with 2 layers of insulation on them coming from the back pins and onto this. Oh, that also alludes to how they do the multiple adapters. Because if I undo this screw and this screw, is this going to result in something separating in a convincing... No, it's not actually. Oh, that whole outer bit should come off, but isn't. Oh, it's probably clipped on as well. Oh, there it is. That's strange. I wonder if they... Yeah, no, it must just be the assembly just for the UK version. But yes, all in all, this wondrous mess that's never ever going to go back together again is well designed. Would I buy another IKEA power supply like this? I think I would. It seems to be quite well engineered. Just a couple of other things worthy of note. When you put the circuit board in, this isolation gap, this slot through the circuit board, actually has a plastic blade molded into the case that when you put it in, that comes right through that slot and provides extreme separation. Also, when you put this in, it's got 3 anchoring points that actually push that whole circuit board, 1 up here and 2 down here, that press that circuit board firmly into place. So it's also quite a robust unit. It seems well designed from scratch. You know, it really has been. A lot of thought seems to have gone into this. It seems to be a good supply.